So silver is +1, wants to be +1, and then needs +1, and then sulfur needs -2. So then this would make sense because then it would be silver sulfide, which sulfur, you would change the ending to IDE. Thank you. So for this formula, you would have to look for the polyatomic because there's more than one element. So you would look on the back of your polyatomic chart, which then would get you an ammonium carbohydrate. The next one is Li3 and then P. So Li is lithium, and then we then know that P is phosphate and then phosphide, which we would add IDE to the end of it. Then we have CuCl2, so that is Cu is copper, which then can be found on the common transition metal chart, and then you would evaluate that Cu is +2, needs a +2, so actually, yeah, +2, and then to cancel out chloride. So then it would be coplic chloride, and then the copper would then have a 2 next to it, and then chloride would have an IDE. You'd then find out that it would be Fe +3 because it's ic at the end, and then that would be a 2, and then oxide, which then would need to be 3 to cancelize it, which then finally would be this. The next one that we have is aluminum nitrate. Now this is the first polyatomic element that we have, and aluminum would be Al +3, and then nitrate you would find on the polyatomic chart on the back of your PT, and then you would figure out it's NO3. So then in order to cancelize it, the final answer would be AlNO3. This, as shown. Next we have titanium sulfate. This is another, you're then using another, sulfate is a polyatomic. So titanium is using 4 electrons. So in order to cancelize sulfate, it would be Ti, and then sulfate would be SO4 and then 2, as shown right there. Next we have formulas and then give the name. So next one is NH4, and then script 2, and then CO3. So for this, so my name is Sam Lindeman, and I did ionic compounds with Josh and Aiden Monado. So my ionic compounds, I did on how to name a basic element. So first it is the element metal, non-metal, or polyatomic? If it's metal, then you look on the back of the chart to make sure if it is a common transition metal, and then if it is, then this can be named with the element symbol with its appropriate ion count in numeric number. And then if it's not, then it's a regular metal on the PT. This element would then be called by its given name. And then if it's just single, then adding an ion after the element. For example, I have hydrogen ion, so that's just single. And then if it's a polyatomic, then the element is found on the polyatomic chart on the back of the PT. This element is then called the given name. And then if the element is a non-metal, which then means you need to find the stem name and add a IDE to the ending. So I'll take you through a couple examples. So first example on the sheet is calcium chloride and how to write that in a formula. Calcium chloride, going through my graphic organizer flow chart, you would first find calcium, which is Ca. Then you would find chloride and find that chloride needs 2 in order to equal calcium. So it would be CaCl2 as shown right there. Next we have ferrous oxide, ferric oxide. Now ferric oxide is one of the ones that you would find on the common transition metal chart.
My name is Ed Maldonado. I was assigned for the flow chart actually covalent bonds, and so I will be teaching how to name and write formulas for covalent bonds. So if a covalent bond is between 2 nonmetals, so you'll have 2 nonmetals, so that's on the right of the staircase on your periodic table. Then, once you decipher what kind of element or atom they are, then all you have to do is look in the name, the formula that's given to you. So, for example, if it was S2O, then it'd be disulfur monoxide. So, because there's 2 sulfur atoms and there's 1 oxygen atom, and that's in the back of your PT, decipher the meaning prefixes. And so with the first word for naming, the first word would be always the full name, so it's not abbreviated. So for example, it would be phosphorus, not phosphide. So if it was 1 sulfur and 2 oxygen, then it would just be straight out sulfur dioxide. You do not put a prefix of mono in the front. Now for writing, now you look at the chosen or the name of the formula, then you see if the first word has a di, tetra, and etc. all the way up to deca for a prefix in the front. If not, then that means it is one of the element in that sequence. Sorry, the memory on my phone just ran out. So so writing a formula, so you look at this first one, di and up, never mono like I said, so then that'd be 1, so let's say you decipher the cation, and then the anion, you just look at the number in front, so mono and up, there's always mono and it's always abbreviated, so then with the prefix, that's just how you decipher how many atoms are in that. So I'll show you it's really small, I'm sorry. It's right here. It's really crumpled. Basically, it says decipher the 2 nonmetals. Look at the metal in front. Look at the prefixes, and then basically leads to naming and writing sequences or formulas for covalent bonds. Thanks, Mr. Rustad.
Hi, I'm Josh, and I will be showing you how to name and write acids. So I'm going to start with names to formulas, and the one I'm going to start out with is acidic acid. So based off the flowchart, I'm going to look at which polyatomic ion and base it off of with its connected acid name. So since it ends with an IC, I know that it started, the ion ending was ATE. And so based off of its acid name, we're going to turn it to its anion ending, which is acetate. And that is C2H3O2. And because this is an acid, we have to add an H to the front and write the correct subscript to make an equally balanced acid or an equally charged acid. but since C2H3O2 or acetate has a -1 charge, we don't have to change the H because it has a positive charge. And now I'm going to move on to a hydronitric acid. And that is different because it actually is not a polyatomic ion. So I had to make a different flowchart. And this one says, look at the acid name, and if it is hydrostemic, then this acid may possibly not be a polyatomic ion and be an element. So if you check the polyatomic ion chart and you do not, the stem and the I doesn't match, we're going to continue. So now we write down the element letters, which nitric, so that is nitrogen. And so we end there. And now we write the H in front of it. And to make this an evenly charged, because of nitrogen being a -3, we have to put a 3 here for hydrogen. So it's an evenly charged. Now I'm going to move on to formula to name. So the polyatomic ion we have here contains both hydrogen and oxygen, so we move her to this side of the chart. And because SO3 is sulfite, it ends with ITE, so we go here and you have the stem, which is sulfur because of its sulfur, but it's sulfite right now. So it's sulfur, and we add the OUS on, so we have sulfurous. And then, like it says here, you just add acid. And because this isn't a regular stem, that's why it's just sulfur, not anything else. So now I'm going to move on to HClO3. And now this also contains both hydrogen and oxygen. So we're going to move over here. And when we look at the polyatomic ion chart, that is chlorate. So we're going to move down to the how to name acids, and ATE gives us ic. So because of it being chlorate, the stem is chlor, and then so we add the ic, chloric, and then you add acid, you have chloric acid. So our final answers, so you have H2SO3, and that will turn into sulfurous acid. And then you have HClO3, which will turn into chloric acid. When we move down, going from the name to the formula, we have acetate, which will go to HC2H3O2, and hydronitric acid, which will go to H3N. Thank you.